Welcome to Planet Geo, the podcast where we talk about our amazing planet, how it works, and why it matters to you. The light's on.
Are we on?
The light's on. Blinking red.
I'm so nervous.
Got my Planet Geo hat on. How do you like it?
I know. I'm mad. When is my merch going to show up?
The white glove service hasn't brought it to your door yet? Man, what's up with that?
I was going to surprise you with one size too small shirt, so my pipes pop.
Yeah, okay. Yeah.
And a hat.
Okay. I can't wait. We're going to turn the camera off for that episode when that happens. Yeah, man. Got the merch on. You can get your own, planetgeocast.com. There's a merch page there. You got a text from your mom. Did you get another word of the day from Joyce?
I did. And I sent it right to you.
What was the word?
Well, hold on now. You're putting me on the spot. I can't remember. She has a lot of things that she says, but I don't understand this. Trucker. Why is that the word of the day?
You know what? That's a great question. Why the heck is trucker the word? Chris, you and I, we say a lot of interesting words every podcast.
Yes, and she picks out trucker.
Was it because we use trucker hat?
Because I said it's a trucker hat, right? I think that's, yeah.
That's not an interesting word, Joyce.
No, Joyce.
We must have said something better than that in that episode.
Hey, somewhere in her subconscious, she's hearing us say Joyce, and she's going to wake up.
She's going to just woke her from her slumber of listening to this episode.
Yeah,
perfect.
We're gradually nudging her to wake up. Being alert.
Think about find a better word out of this episode. We have some pretty good words in this episode, Chris. Don't you agree? This is a fun word episode.
I think so. Yeah, I absolutely do. In fact, I called you one. Just one of the words.
One of the words. Yeah. Well,
called you.
Yeah. Some of them you might be able to call your friends in a joking manner. There's an origin story to this episode. The origin story here is I got a text from my an individual I call my uncle. He's not really my uncle, but close family friend, uncle, who texted me and said, I don't really get texts from my uncle, but I got a text from him, and he said, question, I know from growing up and farming that boulders move up in the fields. Do they move up in lake bottoms? I thought, wow, that's a really interesting question. And that would probably do a pretty good job as a podcast episode. But then we kind of went into a deep dive on this one, Chris. And it's like, at first we're like, okay, that's a pretty short episode. That's really easy to cover. Frost heaving, pretty simple. It's actually more complicated. I mean, I learned something putting together this episode, for sure.
I agree. I have a thought, though. I was wondering, since I'm an old family friend, can you maybe call me your uncle?
Absolutely
not. Can I be Uncle Chris?
Absolutely
Why not?
Uncle Chris.
Why not? I feel like I've earned that.
No, you haven't. I've already got an Uncle Chris. Thanks. I don't need another. Yeah. I do have an Uncle Chris. Yeah, my mother's side. No, I'm not going to call you Uncle Chris.
Once. Just one time.
Not ever, probably. I'll call you other names, but not Uncle Chris. Okay, so this was a fun episode. People might have heard the term frost heaving. Chris, you must cover frost heaving in GSI 1, in earth science even, 9th grade earth science.
Oh, sure. Absolutely. It's such an important thing. I don't like the term frost heaving, though, or frost wedging. I don't like that. So I don't use it, actually. I use the term ice wedging or ice heaving. Yeah. I just don't, I think that's a more appropriate term, ice wedging versus frost wedging.
Yeah. And it actually fits better with the sort of model. But if we frame this, and I think people listening to this have probably heard this or seen this. If you're driving around, you drive past farms, you'll usually see, at least in the northern latitudes where I live in Pennsylvania, up in Michigan for sure, you see boulders near the fields, like a big pile of boulders somewhere, right? And this is very common. This happens in farmers' fields, especially in farmers' fields. It happens naturally, but it happens much faster in farmed fields because of the tilling process. We'll talk about that. But this is obviously a big problem. A bunch of boulders or even little stones damage equipment, decreases like the soil surface area over a big plot. Like this is a big problem. They make devices that you can use to pick up all the boulders and then you pile them somewhere. As geologists, Chris, have you ever just rocked up to a farmer's field and been like, hey, I see a pile of stones. Can I take some?
Absolutely, I have. But here's the thing. The point I want to make is that now they're selling them.
Totally.
And for a lot of money, Jesse. It's amazing. I was just walking past, I was taking a dog for a walk, and they had this farmer had on a flatbed semi truck all these boulders that he had taken from his farm field and placed on there. And he had price tags on
Oh,
each of
really?
them.
On every one? Wow. Amazing.
Yes, yes. And they were priced according to how pretty he thought they were. And there were rocks that were maybe the size of 2 beach balls, if you will, that were like $750 a piece. These were not cheap.
Yeah, well, this is the
was,
same. I mean, it's amazing to me. We were up in New Hampshire too, and it's the same thing. I mean, rocks are everywhere in New Hampshire. The rocks in Michigan, because it's just glacial kitty litter, as you describe it, you get really beautiful rocks. I mean, there are some of those rocks that I've seen in farmers' fields that I would pay
Oh,
a
they're
lot for
stunning.
because they are spectacular rocks. And they're big and beautiful, and people put them in their landscaping or all sorts of things. So you can't just take them because there is value there. And I've noticed the same thing, like maybe a while back, people would just be like, yeah, sure, get him out of my way. But now it's like, oh no, that's worth something to people. And actually people pay a lot to kind of put it in their landscaping typically.
Yeah. So I was talking to the farmer, and he sells them also to landscapers.
Yeah, absolutely. Because who doesn't want a big, beautiful rock in your yard, in your landscaping? Everybody
I
wants
know.
that,
And
right?
they are really pretty. I mean, he had some just stunning rocks out there, nice as you and I are a fan of nice,
Oh
but
yeah. None of them struck your fancy?
I don't buy
Yeah.
rocks. I don't buy
There we go.
rocks
Okay, there we go.
because I go get my own. So
Exactly. Okay. So
yeah.
that's the stage. We're talking about why this happens, and specifically in farmers' fields. Like, why is this happening? Why do rocks continually come up? Why do you have to keep removing the rocks year after year after year? It's a good question. We're going to tease a couple different threads here as to why this happened. But yes, it kind of happens around frost heaving is kind of the
Well,
process.
you did a pretty good job here, Jesse. You came up with a couple of analogies. I think that they make sense. I guess maybe I don't know. I have a question, but why don't you go ahead because it's yours? Why don't you throw your analogies out, and then I have a question about that. I'm not setting you
You
up.
mean say the analogies, not get rid of them because they're terrible. Lose the analogies.
No, I like them actually. They're good, but I have a question though about applicability.
Sure. Okay. So the first way we're going to talk about this, we're going to talk about how does big stuff move to the top. That's a bit counterintuitive in many ways, but also we've seen this in our daily lives. There's a couple main mechanisms, 3 main mechanisms by which you can get big particles move up to the top. And that's what's happening in a farmer's field. The first one isn't really applicable to the farmer's field, but it's applicable elsewhere in geology, is by shaking. And so, Chris, I want you to sit there, Chris Boyce, and imagine your big giant vat of Skittles that you have. I mean, Chris's dream.
It's got to be a bag of Doritos, don't you think?
Okay, yeah, you're right. Okay, Doritos is better. All right, a big bag of Doritos. Perfect. All right, good. Fair point. A big bag of Doritos that you bought at the grocery store, a big family size, party size one. Bought at the grocery store.
Absolutely.
You chucked it in the back of your vehicle. You brought it home. You smashed it in the cupboard, and now you pull it out. And now you're about to eat it. What's at the top? And the same thing goes for cereal boxes. What's at the top? The first half of it is big, beautiful Doritos chips, right?
Yes, absolutely. The big full chips.
The big full ones. You get a lot of salsa on that one.
Unbroken. Yes,
all the good
absolutely.
stuff, right?
The ones you pick out of the bag and you look them over, and which side do you want to have on your tongue? The one with all the stuff on it, right?
This is amazing insight into Chris Boyce's Dorito habits. I mean, my goodness, inspecting
They're ridiculous.
Which one's the best.
You don't do that?
I haven't had a Dorito in kind of a while, I bet. So, yeah.
I haven't either. I haven't had a Dorito in 12 hours.
12 hours.
I'm into chili cheese now.
Chili cheese. My goodness. Okay. Yeah. All right. So big bag of family's party size chili cheese. Now, Chris, what happens when you get to the middle, the bottom third of that bag even?
Then you get some broken ones, right? And then they just get smaller and smaller and smaller, which I like. Because when you get down there, then that stuff gets all in your fingers.
Oh,
right?
yeah. Okay. Yeah. I mean,
but they get the chips get
here.
Smaller and smaller. You get crumbs down at the very, very bottom of it. Absolutely. Okay. And there's a reason for that. That's what you're getting to.
That's exactly right. There's a reason for this. And the classic, many classic examples of this, but it's okay, you could do this with a jar of mixed nuts. You get the big ones rise to the top as you shake them side to side and up and down. The big ones always kind of rise to the top when you shake it. So during shaking, what's going on? Well, what's going on is when you shake stuff, the whole kind of package, you can imagine all the particles are kind of lifted up in the air during the shaking, which means that small gaps form between all the particles. Now, as they fall back down, the small particles more easily fill in the small gaps. And there are very few big gaps that get formed. They are there, but they're very few. So there's actually very few places for the big particles to go when the whole package of particles falls back down. So if you do this enough, up and down, up and down, up and down, up and down, the little ones, they find a nice home down lower. They settle down in because there's a lot of small holes for them. But the big ones don't find any home and kind of get filtered up to the top. They're kind of the weird ones that get left behind, basically. So that's the process. It's a really simple process, but that's what's happening, why big stuff moves up when you shake it.
You get the same thing with cereal boxes, like Raisin Bran does this. The raisins kind of sink to the bottom. So you got to shake it up because everybody wants the raisins with, you want even distribution, right?
Exactly. And we think that the raisins are heavy, but the raisins are small is the reason they sink to the bottom.
That's right.
The raisins are,
that's right.
I mean, heavy has something to do with it
That's
too.
why this is counterintuitive, because the big rocks are heavy, right? And so you have the same thing going on. But here's my question, Jesse. Where does this kind of thing happen then from a tectonic or geologic setting?
Ooh, where does shaking happen?
Yes.
Yes. Earthquakes can do a lot of shaking. So you can have these things kind of pushed up. It does happen a little bit in like a field, in a farmer's field, for instance. And we've talked about this before. It's very similar to the sort of frost wedging. It's the freeze-thaw cycle. The freeze-thaw can do a little bit of lifting up, and then it comes back down and lifts up and comes back down, lift up, come back down. So it's like very slow shaking. That is a force that can get big stuff to the top, but that's not fast enough.
And every freeze thaw, right?
Every freeze thaw, little ones,
the little stuff is going to settle preferentially down to the bottom, thereby leaving the big stuff on higher up.
It's exactly, Chris. We talked about this with soil creep before, where freezes and it gets pushed out away from the hill, like kind of angled out from the hill, and then when it thaws, it falls straight down. So it goes out and down, out and down, out and down. Here we're kind of shaking it's kind of a little bit like a shaking pattern. But that's not really the process that's happening for farmers' fields, because, the freeze-thaw cycles, there's a bunch of them in a typical Michigan winter, but not enough to move a big boulder all the way up to the top of the soil. Like, it's not going to move it that much during this process. So there's got to be something more important that's happening in Michigan.
And that leads us to ice wedging or ice heaving. Okay, this is what everybody would come to. This is such an important mechanical weathering process, right? In the mountains and really anywhere where you get a cycle of freeze thaw, freeze thaw, freeze thaw. Because when water freezes, it expands by 9%. That's the heaving part. And then it melts, and that water then seeps deeper down, and so on and so on. And that can happen in a farmer's field. Right? Let's think about this a second. So you have water that's sitting in the pore space in this glacial kitty litter till, or in the soil that's got these boulders in it. And you get these freeze-thaw cycles. So the freezing is going to heave everything a little bit up. And then when it thaws, the water's going to melt, and it's going to also, at that melting, not only is the water going to seep down further, but so are the small particles. They're going to just go with it.
Yeah,
right?
Exactly.
And so you kind of get the net effect is this like very slow but monotonous kind of heaving up closer toward the surface.
That's right. And that's very similar to the shaking. It's slow shaking, what we kind of talked about before. The question is, can this drive big boulders very high? Or if you've seen this, I had this in the road right outside of our old house, had a massive frost heave in it. It wasn't huge. It was very high. It was very pronounced. It was maybe a foot high, but it was like 3 feet wide. So it was actually like, this was a big thing that pushed up through the asphalt. And it was just a frost heave, it'd come up and then it would.
You said asphalt right there. You just said asphalt.
I said asphalt. Okay. Asphalt. So it's the Michigander in me. I can't,
I know
some parts, sometimes it comes out, even though I have to fight it, try and suppress it. No, I'm kidding. So, one of these things, a frost heave, can we produce these big pronounced like little hills or hummocks, or get a boulder several feet up in the course of a single winter? The answer really is no, not that fast. And we can kind of think about this. You said 9%, ice expands broadly 9%. So if we have soil that's 50% water, which is a lot, that's a lot of water in a soil. If it freezes, it expands 4.5%. So we can't really push stuff up dramatically with this process. And here's where it gets more complicated. And here's how what we learned putting this together, Chris, I think this is a new process or a more detailed process.
It's it's a more detailed version of the story
of frost heaving, which is something I will bring to class now. This is a thing that I'm going to bring to class. I'm going to talk about because we've seen it in Pennsylvania. We see it all over the place. Is what's called ice lensing. And it's a similar process, but different. And the way to think about this is you have to think about what gets cold. Where does the cold come from, right? It's coming from the air. So the surface gets cold, the surface freezes, and then that frozen soil freezes downward as it cools down. So the deep down, it's hotter, it's warmer. And so there's liquid water down below this freezing front as the freezing front moves down. And what you can get is you can actually get a capillary action where the freezing front attracts more water up. And if that water can percolate through the soil fast enough upwards, it's warm, it'll hit the freezing face, and it can actually form a layer of ice. And then these things grow outwards, much like kind of columnar jointing things, right? They kind of grow perpendicular to the thermal gradient. And so you can grow these kind of ice wedges in a layer, and that has a lot of power. If that continues to grow, that can just push a big wedge underneath of the material. And this is actually how we get boulders moving up, because this happens more under larger particles. It's more likely to happen under large particles than under small particles. So if you have a boulder with a bunch of sand around it, you can get an ice lens that forms under that boulder. As that ice lens grows, it pushes the boulder up. It doesn't have anywhere else to go but up.
It's like a nuanced version of ice wedging. It's just a little more complicated. And again, I want to just make sure, because maybe a lot of people are familiar with this, but maybe some aren't. Capillary action is the way that water, because water's a polar molecule, water's attracted to water. It behaves like it has this electrical nature to it where opposites attract. So it's kind of like if you take the edge of a Kleenex and you dip the corner of a Kleenex into a glass of water, just a corner of it, water will rise up through the Kleenex. And,
nice analogy,
it's rising
Chris.
up through those. Yeah. It's rising up through those little hollow fibers of the Kleenex. They're little tiny hollow fibers, right? And they rise up through there, what we call capillary action.
Exactly. I really like that analogy. That's a very good one. And so, what we're going to picture here is that we have a stack of Kleenexes, layered on top of each other, and we put a little water on the bottom one, and it can go all the way up through these layers of Kleenexes. If the top is frozen, the water will go hit that freezing front and it'll freeze, and we could actually produce an ice wedge in between layers of the Kleenex, in between the stacks of the Kleenex,
which gives you a much more efficient lifting.
And this can be kind of a runaway effect. If you start an ice lens somewhere, it's going to start attracting water, not just from right below it, but from the sides. And as it kind of grows into this wedge shape, it kind of grows and pulls in from the side. So it gets kind of more localized. And that's a good way to do this. And so here's one of the fun terms, Chris, that is applied to these is called frost jacking. And this is where you are pushing a single object up dramatically. I mean, these things we've engineered ways around this, but sort of like concrete pilings in a soil layer that is very permeable could get pushed up 2 feet per year or something like that. I mean, massive amount of frost jacking.
I think the main way you can get the same thing with a deck, your corner posts and things like this. The main way to avoid it is to get below the frost line. Get deeper than the deepest place where these ice wedges or ice lenses can form.
I mean, then you can't, the frost jacking can't get underneath of your concrete piling, basically, right? Yeah. And this is why,
if you dig shallow posts for a deck and you live in an area like I do, like let's say you only go down a foot, so the bottom of your post sits a foot below the surface. Well, if the frost line goes down below that, then you probably will actually get this mechanism that's going to then throw your deck out of kilter.
Oh man, yeah. You're just doing a deck edition. Hopefully you went deep. Hopefully you got your tractor out there and dug deep enough.
I know what I'm doing.
Chris's deck building services. Also,
yes.
give him a call.
I am a handy guy. I know what I'm
um,
doing.
so you can imagine where in cold, very cold climates, places where there's permafrost, in places like Michigan or Pennsylvania, where you do get relatively hard winters, this can be a big problem, especially out in the Dakotas, for instance, where it can freeze down 5-6 feet deep in the wintertime. Sometimes you got to go deep. There's an additional layer of engineering that you need to do to kind of drive this, or to kind of prevent this.
That's right. So keep that in mind. These ice lenses that can form, like stacking the Kleenexes up on top, and then you get wedges in between that really is more efficient lifting of that expansion. But combine that with tilling. You're constantly tilling up this upper surface, which allows water to percolate and drain and leach through much easier.
Great point, Chris. Like, we have to think about why farmers' fields. Why are there so many boulders coming in farmers' fields, but not in the grassland right next door, or not in the forest right next door, right? And think about what we've talked about. First, there's a couple things, right? And you talked about one of them. You're constantly tilling up the soil. Okay, what does that do? It makes more room for water. Fundamentally, we're getting more water down deeper,
Making it more porous.
more
Absolutely.
porous. So there's more water. So therefore, this frost wedging or this frost jacking process, these lenses can get bigger because there's just a larger supply of water readily available. Now, the other thing is that we have to think
Can I
about.
hold on? Can I just, I want just to double click on that a second. Because the reason is because when you churn that soil up by tilling it, you get mostly percolation. Whereas on a grassland or in my backyard, in your backyard, you get a lot of runoff. The water's going somewhere else instead of down to feed these kinds of ice lenses in the wintertime.
Yeah, totally. So the other point that's relevant here is we have to consider what types of soil are good for really percolating water, or this capillary action that you talked about. And so think about soils that might be very good at driving this capillary action. They're going to be porous. They're going to be permeable. So there's going to be a lot of holes, and they're going to be all interconnected. Okay, good. But conglomerate is a very porous, permeable soil, but it's not great at this capillary action because the holes are big. So we want fine particles that have a lot of holes in the soil, and also those holes are interconnected. So loamy soil, really fine sandy soil, these are the ones that are really good for farming. And they get tilled a lot, and they're very good at having this capillary action happen. So the same soils that are good for farming, like loamy, silty, fine sand, those are also excellent at transmitting water between them and driving this frost jacking process.
That's right. So there's one final thing before we begin wrapping this up, Jesse, which is this tilled up soil. I don't mean to contradict myself by saying that most of the water percolates down in, but you still are getting some runoff. And because of the looseness of the soil, now you churned it up, you're helping along the erosion process. You're removing some of that loose, easily removed stuff at the surface, which is kind of like by default bringing those big rocks closer to the surface.
Yeah, exactly. So you could expose by erosion, you can just expose the big rocks because they're not going to get carried away in the rainwater. And this would happen. You got to think like, okay, this frost wedging process, it's going to happen in the temperate climates that you live in Michigan and where I live in. It's a very active process in Pennsylvania, Michigan, the Great Plains, the northern Great Plains especially. But it's not going to happen much unless you have cold climates, cold weather. So how do you get boulders exposed in fields in southern climates? This sort of soil expansion is one way, but especially on a slope, if you rinse away the soil around the boulder, you can get these things exposed too. So,
Absolutely.
if you're tilling it up frequently, you're always bringing new soil to the surface, and it can get washed away.
But there was a tag on question, which is, does this happen beneath water or in bottoms of lakes or oceans, right? That was
that was the
add-on.
follow-on question. And we can kind of work through this towards an answer, right? Like at the bottom of a very, very deep lake that doesn't freeze all the way through, it's not going to happen because we're not doing this frost cycling. We don't have a lot of ice. There's no ice down there. It's all water all the time. And also those lakes, they're depositing stuff. There's deposition happening. Even in these beautiful clear lakes in Michigan, you're going to get biological material deposited, etc. It can happen, however, in shallower areas that freeze. So if you have a big flat area that's shallow and it freezes all the way down to the bottom, you could potentially drive this process depending upon how deep the frost layer goes in the soil underneath of the lake bottom. So yes, it could happen in shallow water if you're freezing all the way to the bottom. But I mean, in Michigan, shallow is like a couple feet. We're not getting.
And it's a lot less likely because you have to get below the frozen layer of the water and then continue down. And so you're not going to get as deep into the soil. Therefore, you're not going to be as likely to heave up these massive rocks that are buried in it.
Exactly right. So how would you get rocks exposed in areas like that? Well, wave action is a great one. Running water, if it's in a river, obviously is going to sweep away the sand size stuff and expose the boulders. But wave action can do this too. And we notice this in Michigan, Chris. When we go looking for rocks on the shores of Lake Michigan, any big storm, and especially over the winter, you get a lot of turnover. So big storms will do a lot of turnover, and ice coming, especially on that west coast of Michigan. We have the wind blowing across, and you have ice piling up and doing a lot of erosion. Maybe not erosion is not the right word, but moving the soil around, the beach sand around, exposing rocks, moving them around. So there's a lot of stuff that happens on the beaches in ways to expose rocks every season, basically.
Different process, usually.
Totally different process, than what we've been talking about. But I mean, Chris, as geologists, aren't we just always interested in getting rocks to the surface? Like, this seems like a good problem, But I'm not a farmer who's dinging up my equipment on boulders. But personally, I'm happy that the boulders come to the surface because we get to go look at them, and they're very cool.
I know. I am too. I'm just disappointed that they discovered that they're actually worthy of being sold.
I know.
Like,
yeah.
I want the days 15 years ago, 20 years ago, where they didn't care. They're just like, take my rocks.
Yeah, get them out of here. Get them out of my way. Yeah, I know. It's true. I haven't asked anybody to do that in a while. Maybe I should attempt it a little bit. The problem is, there's a lot of these areas that, especially around here in eastern Pennsylvania, there's some very cool outcrops that are very localized. I mean, we were looking out in, where were we? Right in Maryland, across the Pennsylvania border, there's this beautiful outcrop of a basalt that has been chock full of epidote. So it's this bright pistachio green with quartz veins running through it. It's a spectacular rock, but it's exposed in a road cut, like a highway road cut that's really busy and right next to the road. So it's like pretty sketchy to go, get up on the cliff and collect anything because there's cars whizzing past but you go right over the hill and there's a bunch of people who have this stuff laying around in their yard because they're sitting on this outcrop, but it's a really like localized outcrop. And I was over there with a buddy. This was maybe 6 months ago. We were going to go knocking on doors, but it was getting dark. And we're like, you don't want to be the people knocking on doors right when it's getting dark. That's a way to turn people off. You want to go there on like a Saturday morning, and knock on some doors. But that's the last time I considered it.
Well, I think, I think you need to do a midnight run to the outcrop when it's not as busy.
That's true. Bring some headlamps, and that's a good point.
You just need to figure this situation out, Jesse.
Yeah, I know.
It's not that difficult.
I'm being a rookie over here. Like, what's going on? Well, when you come to Pennsylvania, we'll maybe go check it out.
Deal. Is it a vesicular basalt? Is that where the epidote sits?
No, it's like pervasive. It's like throughout. It's kind of overprinted the almost entire basalt. It's really spectacular.
So do you get any crystals, or is it just a smearing of epidote?
It's like a big smearing, and it's like big veins too, but it's not crystals of epidote. It's just like that pistachio green. The whole rock is that, and there's quartz veins running through it that are smoky or white quartz running through it. It's very pretty, but no crystals to speak of.
Awesome.
So
All
right. Well, Chris, that's a wrap, right?
Yeah. It's a wrap.
I think if Joyce doesn't pick frost jacking as the word of the day, I'm going to be a little upset. I'll be honest with you.
I don't know. There were a couple other ones. There are options for her. She'll, hopefully she picks something other than till or, something like that.
You know what it's going to be? It's going to be Doritos. That's going to be the word of the day.
She knows I love Doritos.
Yeah, I know. That's why
she knows.
Be like,
but
Doritos.
When I was a kid, she bought me the knockoff brand, and there's no knockoff of Doritos. It's the real thing.
That's why she's going to think, Doritos. Chris. I love my son. I wish I'd given him real Doritos when he was growing up. And then that's going to be the word of the day. So
if any of our listeners are Dorito executives, I will be glad to be the face of Doritos.
Chris will gladly accept unlimited supply of Doritos at his house for mentioning Doritos on the podcast. Yeah.
Oh,
Chris is just, and Skittles too. If anybody out there works for the Skittles company or whoever makes the Skittles.
That's right.
Let them know, because
yes.
Chris is accepting donations at his house of Skittles and Doritos. I could just see you munching away on Doritos in your tractor. You probably got like a little homemade chip bag that you made on your tractor just for the Doritos, don't you?
That and a beer holder. So I'm good to go.
And a chapstick holder somewhere on that thing.
Ooh, I don't have that yet, but I need that.
Got to get on it. Unbelievable. Unbelievable. All right. Hey, that's a wrap. Thanks for listening. There's a couple ways to support us. First of all, we got merch. Go to our website, planetgeocast.com, and there's a merch button there you can buy. Right now, we got hats and shirts and some other stuff coming online pretty soon here. You can also go to our Camp Geo mobile app, where we have visual podcast series that are available for purchase there. And there's a lot of free content as well with all the images. Geology is such a visual science. You got to use the images. They really add to the value. So if you want to learn, go there. Camp Geo app, first link your show notes. Send us an email, planetgeocast@gmail.com, and follow us on all the social medias @planetgeocast.
Cheers.
Peace.